Hello there, it's Alana Tucky. I'm back for more calculator tutorials. This time I'm going to show you how to use your calculator to find binomial probabilities. And actually we're going to find both binomial probabilities and cumulative binomial probabilities, which are both super useful for answering questions. Alright, so I have this problem right here where we had the number of successful free throws out of 3 tries, where the probability of success, this was back a ways, was 0.77 for an NBA player. And we're going to try to find these probabilities without having to do this whole tree diagram business. That would be a chapter 5 issue. Okay, so the way that you enter stuff into binomial is there's Binompdf, and it's going to go n, comma, p, comma, I'm going to put x in brackets, and I'll explain what that means in a second. Okay, so for this problem, it would be Binompdf. Now we're trying 3 shots, so there's our number of trials. Our probability of success is 0.77. For this particular one, it would be 0 because we want to know about 0 free throws. So let me grab the calculator. Clear. So now where is Binompdf? Well, it's the probability distribution. See above the various button where it says DISTR? That's distribution. So you go there and you kind of scroll down until you find what you're looking for. Oh, there it is. For me, it's letter A. Different calculators might have it as letter 0 or number 0 or whatever, but I have it as A. So I'm going to grab A. And now it's asking me how many trials did I have? Well, I had 3. Then I press enter or points or down will work. And then I had 0.77. Now what x value do I want? I want 0. And then I go to paste. And it pastes it all up in there. Now if you have an old school calculator, you actually have to type it like this, 3, 0.77, 0. New calculators, you just fill out that menu and it'll type it all for you. So there you go, 0.012167. So let me type that. I think that's what it was. Let me double check that. 0.012167. Yes, right. Okay, then you could do it all again, right? So you could go back to distribution. I want letter A, so I could click letter A. And then it wants 3.77. Now I'm going to want 1. So I go down here to x value and type 1. Press enter, paste, and you have it. Okay, so you could keep doing this, but it's kind of tedious, especially with so many that we'd have to do. And this one only has 4, so this is actually not too bad. But what if we kept going and did more? Let me, what was that? Oops. Where's my calculator? There it is. 122,199. All right, so let's round this. 0,121. How about that? And then this was 122,2. Okay? All right, so you can see this is going to get annoying. All right, now there are some ways we can make this quicker for ourselves. So one thing we could do is we could actually just press second enter. After we've done it one time, it'll bring up the last thing we entered, and then we can just go in there and type the number 2 and press enter, and it'll find it. Okay, so that's nice. The other thing you can do is you can leave the x part blank. That's why I put x in brackets. So I want the alpha key. So I'm going to go 3, I'm going to say 0.77, and I'm going to clear this out. So I'm not giving it a specific x value. So you can give it a specific x value, and when you do, it'll give you specifically 0, specifically 1. But I want you to see what happens when I leave it blank. So I go to paste. So you see I don't have that comma business at the end. So it's just 3, 0.77. That's why when I wrote this here, I put the x in brackets, because you can include it, but you don't have to. And when you don't, what it does is it finds all of them in a row. There's 0 right there, the 0.012. There's 1, 0.122. There's 2, 0.409. And if you hit the right arrow, there's 3, 0.4565. Nice, huh? So they're all in a lovely row for you. So this one is 0.4091, I think it was. 4091. And the next one's 4565. Now the other problem with this is that it's a little bit hard to kind of see all of them. Like we have 4 of them, and that's not too bad, But if we started doing like 20 of these free throws, that would be kind of tricky. So another thing you can do is you can do Binompdf, or Binompdf, excuse me, Binompdf. So I can say I want that, here, let me clear this so you don't get confused. I want that Binompdf. Let's say I don't want the specific x value. I'm going to get rid of that. I want to just have it find all of them for me. But I'm going to store it. I'm going to hit the stow button, store it. I'm going to store it in L2, just for the sake of it. When I do that, it runs it. It looks just like before, but I stored my data in L2. So if I go to Stat and Edit, you can see the numbers right there. Right? And then you could just go over here and fix this. This was 0, 1, 2, 3. And there you have them. That's a little bit easier to read. Again, you don't have to. The store button's not mandatory or anything. It's just for your own benefit. It can be nice. Okay? Oops, wrong thing. All right, so that's how to do the Binompdfs. Binompdfs find exact probabilities. So if you're looking for all, none, exactly 3, exactly 4, that's these ones, these 4. But what if you're dealing with I want the probability of fewer than, or more than, or at least, that kind of thing? Well, then you want Binompdf. You want it to add them up. So again, it has the same issues. It can be n, comma p, those two are mandatory, and then the x is up to you whether you want to put it in. So let me show you how that works. So this is cumulative, it's going to add. So let me go back, let me quit out of here. I'm going to do distribution. Binompdf is letter B for me. So it might be a different letter for you. I have 3 trials. I have a 0.77% chance, 0.77 chance, there you go, 77% chance. And now I could fill in a specific value, like 1 if I wanted, or 0. But I could also leave it blank. So let me try showing you just, if I put it in 0 and I paste, enter, it finds a specific number. Now what if I don't want to do that? What if I want to leave that x part blank? Let me grab that. There we go, leave the x value blank and go to paste, enter. And there we go, 0.012, 0.134, 0.543, like that. See? Okay, so if that's the case, and then I can store them, this is kind of hard to read. So let me store those again. Let me store them. I'm going to store that last answer, that last list, in second 3. I'm going to put it in L3 for myself. And there they are. So now when I go to Stat Edit, I can see there's my x right there. I'm on my PDF in L2 and my CDF's in L3. Now CDF is accumulating, it's adding up. So we've got 0.0121 just like before, but then we have 1 by the end, and then the next one in the middle was 0.13, what was it? 1344. And then, or 1343 and some change, and then 0.5435. Down here. Okay. And again, you don't have to do the store thing. I just like it because it makes it so that it's easy for me to read what's going on. This was a pretty small table, so it's not necessary. And you don't ever have to use it if you don't want to. It's just a way to do that. Okay. So to reiterate, Binompdf, which is letter A, finds exact probabilities, right? What is the probability? Let me grab it. I want 3 trials. I want 0.77 chance. What's the probability of exactly 2? And I press enter and it finds it. That's the chances of exactly 2 successes. Binompdf, which is letter B for me. Oops, letter B. There you go. 3.77, 2. Enter. Enter. Finds the chances of up to and including 2. Right? So the 409 is the probability of exactly 2. The 5434, 5435 is the probability of 2 and less. 2, 1, and 0. It adds them all up for you. See the difference? Okay, so you use this one for, I'll make a little note. So the one on the center is used for exact probabilities. All, none, stuff like that. all, none, exactly, for, etc. Okay. And then this one over here is used for all the cumulative probabilities. So used for less than, greater than, at least is another one, at least, at most, stuff like that. Those tend to, not always, but they tend to use CDFs more often because you're wanting to add up a whole bunch, etc. Right? So there might be a few more, but it's not exact probabilities. They're for cumulative probabilities, when you're trying to find more than one thing at a time. Then those tend to be, not always, but they tend to be CDF questions. So less than, more than, greater than, etc. All right, now you guys know how to use your calculator to do all that. So once you know that stuff, then it's just a question of applying it in the particular problem that you're in. So let me just scroll through here just real quick. Oh, so this one right here, that's kind of a list of all the things. So the exactly one, the bottom one, that's the one where you use PDF. The rest of these ones you use CDF on, more or less. Not always, but most of the time. And then I was going to give you this example. So here you don't actually have to find the full table. I've found it over here. But you have 5% of people being afraid of being in the home alone at night. You have 20 random Americans that you're looking at, right? So the probability of exactly 5, see that word exactly? That's a PDF question. So you're going to do Binom PDF. You've got 20 people that you're looking at. You've got a 0.05% chance of, or 0.05 chance of success. And you want the probability of exactly 5. So that's how you would do that one, right? I'll go do it real quick. Distribution, alpha A, I want 20.055, paste. 0.0022. There you go. Okay, but with the probability of at least 1. Okay, so at least 1 would be everything except 0. So you would find either all 19 of these, or you'd find 0 and then take it away from 1. The thing about 0 is it actually doesn't matter which way you do it. It'll be the same for each one. So Binompdf, because you're just looking for a particular one, 20, 0.05, 0, and then you'll take whatever that is away from 1 to get the rest of them. And you don't have to retype it all. You can just do second enter and go back in and just fix the one number that you need. Right? That's entry. You're taking your last entry. So it's 0.3585. So that's what this number right up here is. Okay, but we don't really want that number. We want everything else, like the rest of the entire table. So to find that, so the probability of at least 1 is equal to 1 minus the probability of 0, which is equal to 1 minus 0.3585, which is 0.6415. All right, I hope that helps while you work on your lovely binomial problems. I hope that helps you find your binomial probabilities. See you later.